LeetCode coding challenge, and today we are going to solve our next problem statement, longest zigzag path in a binary tree. So let's start. You are given the root of a binary tree. A zigzag path for the binary tree is defined as follow. Choose any node in a binary tree and the direction right or left. If the current direction is right, move to the right child of the current node, otherwise move to the left child. Change the direction from right to left or from left to right. Repeat the second and third step until you can't move in the tree. Zigzag length is defined as the number of nodes visited minus 1 and single node at the length of 0. Return the longest zigzag path contained in that tree. So we have given a binary tree. We need to find the longest zigzag path for a binary tree. Zigzag path is for one you go to the right subtree, then go to the left subtree, then to the right subtree, and so on. So we need to find the longest zigzag path. For this binary tree, if we start from the root, first we go to the right direction, then to the left direction. So this is also a valid zigzag path. And length of this zigzag path is 1 for this path, the second for this path, the number of lines. So it is 2. For this, first we go to the right, and if we go to the right, this is not a valid zigzag path. So once we go right, then go left, then go right. And again, if you go to the right, this is also not a valid zigzag path, but this is a valid zigzag path. First right, then left, and then right. If we count the number of lines, 1, 2, 3. So this is the maximum longest zigzag path for this binary tree. Similarly, for this binary tree, first we go to the left, and then there is no node left. So it is still a zigzag path, so length is 1. Similarly, if we go to the right, then to the left, then to the first go to the left, then to the right, then to the right again. This is not a valid zigzag path. From this node, if you go to the left, then again to the right, this is a valid zigzag path. The number of lines is 1, 2, 3, 4. So 4. The output is 4. If there is only one node, the output is 0. There is no zigzag path for one node only. So let's try to think like how can we solve this problem statement. We can use DFS traversal to traverse across the binary tree. What we are doing, we are marking a flag to check if it is going if the previous direction is left or right. So 0 means it is going to the left direction, and 1 means it is going to the right direction. And we have the count. It initialized count value is the number of lines in the zigzag path. So we will keep track of the zigzag path from the count counter. And our logic will be, if our previous direction is left and the next direction is right, we are simply going to increase our count value. So from this, if we start from the root and do the DFS traversal, first we go to the right direction. So our count is 1 and our direction is 1 because we are going to the right direction. And if we go to the right to left, our direction is changed from 1 to 0 and our count also get increased. So here the count is 2, 1 and 2. So if our direction is changing, we are incrementing our count. And let's do it. And if our direction is not changing, if we are going from right to right or left to right, left to left, we are initializing our count again with the value of 1. So previously our direction was 1. When we come to this node, again the direction is 1. So we initialize again our count value with the value of 1. Then again we go to the right direction, this node, and again the direction is same as the previous. So we again initialize the count with the value of 1. If we move to this node, now the direction is 0 and previous direction is 1. So it means we are going from left to right. So we incremented our count and our count goes to 2. Then again we change the direction from 0 to 1, going from left to right, and again we increment our counter value, right? Because we are changing the direction. For this node, again we are changing the direction. For this node we are not changing our direction. We are going from right to right. So direction value is same. So we are initializing our count again by the value of 1. So for this binary tree, the maximum count value is 3. So this is our output. So I hope you understand the solution. Let's do the coding part for this. First, we are defining the DFS logic. So static void DFS. and we are taking our tree node. We are saying we need to keep track of the value of the count and the max count. To define your max count variable, initialize it with 0. Now let's write the DFS logic. If our root goes to null, simply return it. We also need to keep track of count every time we are changing the direction. So let's say define one more variable int count. Here we are writing 0 means left and 1 means right. Now do the DFS traversal again, call the binary tree. Move to the left direction. And also we need to pass the direction also every time, right? We also have a direction variable. So define your direction variable also. Now we are saying if the previous direction is same. So suppose we are going from right to right or left to left. We need to again initialize the count to 1. And if the direction is opposite, if we are going from left to right or from right to left, we need to increment our count value. So while doing the DFS traversal, it's the right direction here. So we are going to the left side. So that's why our direction is left. So our pointer is 0. So we pass the flag 0 because we are going to the left side of the binary tree. Now we need to write the count logic. So we are saying if our current direction, so we are going to the left direction, and if our current direction is 1, if our current direction is 1, basically we are moving from right to left direction. So if our current direction is 1 and we are moving to the left direction, we are incrementing our count value, or else we initialize it with the value of 1. So let's write this. Or we can also say if we are going to the left direction and our current direction is also left. If our current direction is also left, initialize it with the value of 1, or else do the count plus 1. So this is also easy to understand. So if we are moving to the same direction, previous direction is left, and we are again moving to the left direction, we need to initialize the count with the value of 1, or increment the count by the value of 1. Let's copy paste it here, and similar we are going to do for the right side. If we are moving to the right side and the current direction is also our right side direction, so we initialize by our count with the value of 1, or else increment our count value. One more thing we need to do, we need to keep track the max count. So let's say max count will be equal to whatever is maximum between the current count and the max count. It will keep track of the maximum zigzag path. Now, from the root path, there can be 2 nodes. So we need to first go to the left direction, then to the right direction. So call DFS for the left side of binary tree also and right side also. So if we are going to the left, we are passing our direction as the left direction 0, and we are initializing our count value with the value of 1. Similar, do it for the right direction. If we are moving to the right direction, pass the direction as 1 and initialize your count with the value of 1. Max count we need to initialize every time by the value of 0 and return the max count. So our coding part is done. Now let's run the solution if it is working.
Well, I still got this. We say that you block in here. What that need? You have to let me understanding my sound.
Need to define that is a static variable.
and I want to get the thing straight. So keep on you on this.
Okay, so our two test cases working and one is not working. Let's debug it. Expected 3 and 4. Dot left. Yeah, so we are not changing the direction here. If we are moving to the right, we need to change the direction. So the flag for the right direction is 1. Let's run it again. So now our all test case is working. Now let's submit the solution. Yeah, our solution is also working. And thanks for joining the session. Let's meet tomorrow.